Hi, my name's Dan, and this video is one in a series that I'm doing looking at digital electronics and specifically logic gates. I'm looking at each one in turn with a small video of its own, and this time we're looking at NOR gates. So in order to understand this video, you probably need to have some understanding of Boolean logic and Boolean algebra. It doesn't need to be an in-depth understanding, but otherwise you won't see the point of what we're doing here. And it would be good to understand the principles of logic gates, what's going on behind the scenes. And if you want a video which will help you understand that, then the first video in this playlist is one that does exactly that. So now we're going to have a look at the NOR gate. Okay, so what is this? So NOR is not a word that appears in the Boolean algebra, the most basic processes, but it means a Boolean OR followed by a Boolean NOT. Okay, so if you take two inputs and you combine them together using the NOT process or operator, and then take the outputs and apply, combine them together using the OR process, and then take the output and NOT that output, so you invert it. Okay. So a truth table for that process is as follows. We've got two inputs A and B. The gate is symmetrical, like all of the gates, but they are discrete inputs. And there are four possible inputs, combinations of input here. And the only output that gives us a 1 on the output is when both inputs are 0. And if you know your NOR, you know your OR process, you will see clearly that this is the inverse of the OR at the output. Unlike the NAND gate, which there's another video for, NOR is actually a word that appears in the English language. And you can think of this as being neither one nor the other to give this output. So let's have a quick look at this in our digital simulator that I've been using. This is a piece of software called DigitalWorks, which allows you to simulate logic gates and digital circuits. I'm just going to zoom in. I've got to move across there, zoom in a little bit better. There we go. This allows us to do, we've got interactive inputs here, so I can click on these. White means 0, red means 1, and I've got two inputs here, the A and B input. So the symbol for the NOR gate is very like the symbol for the OR gate. It's got the curvy back end here, but what's different is that it has a bubble on the outputs, which on all the gates that have a bubble, this indicates that the output has been inverted. So it's an OR that's been inverted, and we can get that from the symbol, maybe if we know the other symbols. And so for the two inputs, when both inputs are 0, we get a 1 output, but in all of the cases, we'll show all of the cases quickly like that, then the output is a 0. So that's it for the NOR gate, and that's it from me for now.